Okay, so a quick preview or going over the notes that you already took from reading the textbook and filling in your own note sheets. Okay, so you already took a look at this part. Writing, this is quadratic equations and functions. So definition, what a quadratic function is. It's a function that can be written in the standard form, f of x equals ax squared plus bx plus c. Now remember, f of x really takes the place of y. So this is an equation, y equals ax squared plus bx plus c. Of course, a cannot equal 0 because if I put a 0 in here for a, then this thing is no longer quadratic. It would be linear. Okay, so keep that in mind. Quadratic's got to have a quadratic term in it. Example 1 says determine whether each function is linear or quadratic. And then you're going to identify the quadratic, linear, and constant terms. Now, in part A, again, f of x takes place of y. So this is a y equals x squared, subtract this times this. This is a strange way to write an equation, but hey, what you have to do is to get it to look like ax squared plus bx plus c. This does not look like that. So you have to multiply this part out. Multiply the x plus 1 with the x minus 1. You're going to get this, what's inside the parentheses. And then you distribute the I combine like terms first, the middle terms, get an x squared, subtract 1. And then you distribute the negative sign. And then here, the last step, you got to combine like terms. X squared subtract x squared is no more x squared. The answer here is 1. Now, remember, this equation is the equation y equals 1. And folks, we graphed these lines already. This is the graph right here, this y equals 1. That's the graph of a horizontal line. Okay, so this is linear. The base word in linear is line. Okay, so this equation is linear. It's the graph of a line. Now it asks you to identify the quadratic, linear, and constant terms. Well, the quadratic would be your x squared. Well, there is none. Linear term. Now, linear equation and a linear term are two different things, so don't confuse them. Linear is x to the power of 1. There is none. But we do have a constant term. Our constant is 1. Okay? Everywhere on the line, the y value is going to be constant. It's always going to equal a 1. Second example, f of x, again, that's really a y incognito, right? So this really is y equals quantity 2x minus 1 squared. This is not in this standard form. So you have to multiply this out. 2x minus 1 quantity squared means 2x minus 1 times itself. Do the FOIL, combine like terms. If you have a quadratic term, then your equation or your function is quadratic. Listing by terms. The quadratic term is 4x squared. The linear term is the middle guy, the x to the first power, negative 4x, and then your constant is 1. So if you have any questions on this, post on the homework discussion or ask a question in class. Folks, if you ask homework questions, I can make quick, short little videos. Well, as short as they can possibly be to explain the problem. But if you have questions, you don't know what you're doing, come into a Google Meet or, ask for a video. I mean, I'm not saying I can make, 30 videos, but I can certainly make some videos to help you out. Okay. Next thing here was a parabola. What is it? Well, that's what the graph of a quadratic function is called, a parabola. The axis of symmetry. Well, that's the line that divides a parabola into two parts that are mirror images. They will be symmetric on one side and on the other side. Vertex of a parabola. Well, we already know a vertex of an absolute value function. It was the bottom or the top point. Remember, that was a V-shaped graph. Those had a vertex, and so do parabolas. It's the point at which the parabola intersects the axis of symmetry. The y value of the vertex of the parabola is the maximum or the minimum value of the function. So, for some of your homework problems, you got to follow the directions that's on the Schoology calendar. You're going to be asked to give the vertex. You're going to ask to give the equation for the axis of symmetry. And you're going to be asked to give a max or a min. So your max or min happens at the point where the vertex is. Now, the vertex tells us a lot because this value 2, that's the equation x equals 2 comes right from that because your axis of symmetry passes right through the vertex. And the axis of symmetry is a vertical line, up, down. That's an equation of x equals. And it's going to equal whatever x is from the vertex. Always, all the time. Whatever x is the vertex, that's the equation of the axis of symmetry. And then your max or your min value is actually the y. Okay? So, max happens at 2, 3. Max, if this is a max value is 3. And then the AOS, which is the axis of symmetry, x equals 2. Okay? So the max or min happens at 2, 3. The max value is 3. The axis of symmetry is the equation x equals 2. Or maybe this is min. I don't know. I mean, if the parabola opens down, then we have a max. If the parabola opens up, then you have a min. Okay? And you need arrows on your graphs. All right. This part here was identifying the parts of the parabola. It says identify the vertex and the axis of symmetry of each parabola, and then identify the points corresponding to points P and Q. Now, if you have to graph or if you have to get information from a graph, this is what you're going to do. You're always, always, always going to give the equation for the axis of symmetry. That is necessary, always. That's this line right here. Okay, it's a vertical line that passes through the vertex. The vertex is here. It's in this example, it's the min, it's the low point. Okay, so the equation of that line that passes through the vertex is x equals -1. Look at the coordinates of the vertex, -1, -3. So I have a min happening at -1, -3. The axis of symmetry is the equation of the line x equals -1, which comes right from the vertex. And my min value is -3. Now let's look at these points, these corresponding points. So here's point P, and I want the point that corresponds with point P. Well, notice, P is exactly 1 unit away from the axis of symmetry. Its corresponding point would be 1 unit on the other side of the axis of symmetry, this point right there. This point, Q is 1, 2 units away from the axis of symmetry. Its corresponding point would be 1, 2 units on the other side of the axis of symmetry. Folks, when you fold this paper on the axis of symmetry, this side of the parabola would lie directly on top of that side of the parabola. And so that's why it's called an axis of symmetry. It's an axis like the y and the x axes, but it's the one that shows us where the symmetry is going to happen, the left side versus the right side of the parabola. So what are you going to have to give when you do some of these problems? You're going to have to give the vertex. And the vertex here is -1, -3. For some of the problems, follow the directions on Schoology. You might have to tell if there's a max or a min. In this case, it's a min because it's a low point. And you're going to give the coordinates of the min. So the min happens at -1, -3. And then the min value is -3. The AOS, axis of symmetry, is the equation of the line x equals whatever x is in the vertex. All right, so again, if you have any questions about that, post a comment in the homework discussion or ask in class if we are in class. All right, so to continue on with this section, Notes 5.1 continued. You want to pay special close attention to this. It's not difficult. It's really not difficult, but it is time consuming. Okay? So not difficult, just time consuming. So when we're going to fit a quadratic function to 3 points, what we're really being asked to do is, if you look down here, you're going to be given some ordered pairs or a table of values. And they're going to tell you that a parabola passes through these three ordered pairs, and we want to write the equation of it. So this is not a difficult task, but it's somewhat of a long task. So the first thing you want to do is identify the ordered pairs from the table or from the data. Okay, so you're going to identify them. All right, here's my table. Folks, this is really just ordered pairs. Okay, I can put parentheses on it. This is x comma y. Okay, identify the ordered pairs. Okay, we got them. Then we have to use the ax squared plus bx plus c. The y equals that. We have to use it twice. We're going to substitute the x and the y values, which happen to be these values, into that y equals ax squared plus bx plus c. You're going to substitute into that. What are you going to substitute? Well, we know what y is. Y is 3. We know what x is. X is 2. And we're going to do this not just once, not just twice, but 3 times because we have 3 ordered pairs. And this is going to create a system of 3 equations that we're going to solve and find what is the value of a, b, and c. And once we get the values of a, b, and c, we're going to back substitute into this model a second time. If a is 3, then this equation is going to become y equals 3x squared. You kind of see where I'm going with this. So again, not difficult, but you do have to know how to solve a system. All right, so this is the step. Substitute the x and the y values into this model. Then we're going to write a system of 3 equations, and you're going to solve it. You have to, because you have to find what a, b, and c are. And you solve that system using the elimination or the substitution methods. You don't have to do both, just one. Okay? I'm going to write a system and solve using elimination or substitution. And finally, once we get what a, b, and c are, we're going to take those and substitute again. The values of a, b, and c into y equals ax squared plus bx plus c. So that we can write the quadratic function that passes through the 3 points. You can always check your work on a graphing calculator. I'm not going to be able to project that on the screen here. So if you have questions about that, let me know. I can show you it in a Google Meet. All right, write a quadratic function that includes the values in the table. Well, folks, I have to use my model. Y equals ax squared plus bx plus c. I know what y is and I know what x is. Y is 3, x is 2. So we're going to replace the y with a 3 equals a. We don't know what a is. We're trying to find it. This is for x squared plus b. This is for x plus c. So all I'm going to do right now is set up the y's and leave the parenthesis placeholders. 13 equals a x squared plus bx plus c. And then 29 equals a space for x squared plus b space for x plus c. Now, once you have this set up, you can go ahead in and substitute the values of x. Folks, I highly recommend you use parentheses because you'll probably type this on the computer. You know, if x is negative and you square it, it's going to be a positive number. If you don't square the negative, you're going to run into some trouble. All right, so x for this problem is 2, so I'm going to put a 2 in there and a 2 in here. And for this ordered pair, the x value is 3. And for this ordered pair, the x value is 4. Now, we've got some work to do because we're going to arrow over now. And I'm going to simplify the equations, and I'm going to put the y on the right side. Okay? So let's think about this logically. 2 squared is 4. This piece here becomes 4a. This piece in the middle is positive 2b plus c equals what? 3. Okay. This a value is always going to be positive. It has to, whether this is positive or negative, the x is positive or negative, when you square it, it's always positive. The leader is always going to be positive. Okay, please don't make those mistakes. I get students every year, they make the mistake. I can't show it to you here because none of these are negative in the example. All right, 3 squared. 3 squared is 9. This becomes 9a. The middle is 3b. It's plus, right? Because it's positive b times positive 3. So this is 3b. Plus c equals 13. And the last one, square of 4. You get positive 16. This is 16a plus 4b. You know, it just so happens all of these are positive, so that's why it's plus all the way through. All right, now I have a system of 3 equations with 3 unknowns, a, b, and c, and I can solve. So what am I going to do? I'm going to use elimination. So much easier, number 1. Number 2, all the c's are positive. So if I make, I put equations 1 and 2 together, I can make the top equation negative. The c's are going to go away. So I'm going to use elimination, and I choose to always eliminate c because I don't have to multiply by anything but a -1. So I'm going to use equations 1 and 2 to eliminate c. I'm going to multiply the top equation by a -1. That's -4a. Subtract 2b. Subtract c equals -3. Now you have to remember to make them all negative. I'm going to copy equation 2 right underneath it. That's 9a plus 3b plus c equals 13. I've got my opposites right here. They're gone. Now I'm going to add. What do I get? -9a plus, or -4a plus 9a is 5a. -2b plus 3b is plus 1b. -3 and 13 is 10. I need this. I'm going to do the same thing, but this time with equations 2 and 3. Okay, so I'm going to eliminate C again. I'm going to multiply equation 2 with negative 1, so that's negative 9a, right? Because I need to make the C's opposite. Subtract 3b, subtract C, equals negative 13. 16a, add 4b, add C, is 29. I have my opposites, cross them off. See, I want two equations with just two unknowns, the a's and the b's. So the difference between 16 and 9 is 7. This is 7a. Difference between 3 and 4 is 1 plus b equals 16. I need this equation. And I'm going to put, oops, I didn't want to do that. Sometimes this thing works really well and sometimes it's just weird. Okay, so I'm going to put these two together and eliminate B. All right. I guess I'm going to multiply this equation by negative 1. So I get negative 5a subtract b equals negative 10. 7a plus b equals 16. Here's my opposites. They go. I can now add. This is 2a equals 6. So a equals 3. Find the b. It doesn't really matter which one I substitute into. I'm going to use 5a plus b equals 10. A is 3. This is 15, and when I subtract 15 from 10, I get b is negative 5. Choose one of the original equations. I'll use the top one. 4 times a is 3, plus 2b. B is negative 5, plus C equals 3. Here I've got 12 minus 10 plus C equals 3. 12, take 10 away is 2. Subtract 2 from 3, you get 1. Almost done. We're going to write the equation. The equation I don't like the way that looks. It's too thick. All right, so what is my equation? Well, I'm going to use this model. Y equals ax squared plus bx plus c. I know what a is. A is 3. So guess what? I'm going to take the 3 and substitute it in for the a. B is negative 5. That's going to get substituted into B. The C is 1. So my equation, my final answer for my equation is y equals 3x squared minus 5x plus 1. And you graph this on a graphing calculator. And you look at the ordered pairs. You go to the table on the graphing calculator. You're going to see that this does pass through these 3 points, 2, 3, 313, and 429. So if you have any questions, post it on the discussion. Come into a Google Meet. I can't encourage you enough to do all of these things. You can be successful with this. Alrighty, if I hear from you, I do. Hopefully I do. If I don't, I hope it's because you are awesome with this. All right, have a great day.